Hi, buddy. This is Mr. Folly, and welcome to Podcast 3.2 in the periodic table. We're going to talk about all trends are due to size and nuclear charge. All trends are due to size and nuclear charge. All trends are due to size and nuclear charge. We're going to look at what electronegativity is, define it, show the trend. Ionic Radius, define it, show the trend. Reactivity, which for metals and nonmetals are different, but define it and trend. Valence electrons, charge of ions, and noble gases. So let's go ahead and get started. Explain the main way atoms differ, and you just explained every trend. Well, the main ways they differ is size and nuclear attraction. Bigger things are less attractive. High school romances don't last through college. So if, for example, oh great, here's me drawing America. Woo, Texas. Okay. If you go to school here, let's say you go to school at UIC, and your date goes to school at LSU. Go Tigers. There's a long distance here. The likelihood of you making it through 4 years is about 0.0001%. Because what happens is you guys are so far away that, oh, look, here's another person of interest. Oh, look, here's another person of interest, and they're closer. And then it's like, oh, dump, and it's over by Thanksgiving. So bigger is less attractive. Distance makes you find someone else. Sad, but true. Nuclear attraction. More protons means more attraction, because most everything we're attracting here are electrons. We're focusing on electrons, so more protons means it's more attractive. Long distance romances. Draw a periodic table to show size. So you should be able to know the periodic table well enough. You can draw one about this quick. Okay, so size. As you go down, it gets bigger. Why? Because you have more energy levels. Remember how I said we don't have rings? But that makes sense. If you think of it like rings, this is why that persists. More energy levels would make it bigger and bigger and bigger. More energy levels, so that's lots bigger. And as you go this way, it gets bigger. Now, why does it get bigger this way? It gets bigger because you have fewer protons for your row, so less attractive. Okay. So the biggest element is right down here, and the big daddy of everything is francium. Francium is the biggest element of them all. We tend to ignore the noble gases quite a bit. So not including the noble gases, francium, a little bit added. I said francium. Man, oh man. Fluorine, a little bit of fluorine. The cute little fluorine. Electronegativity. Electronegativity is the ability to attract electrons in a bond. Thou shalt covet thy neighbor's electrons. Trend. Fluorine is the Mac Daddy. Francium is a big loser. So if you remember the country of France is full of big losers, then you can remember that electronegativity, France is a big loser. Why? Fluorine is small. Remember we just talked about how it's small? And is attractive because it has so many protons for its row. Let me just hop back to my little picture here. Looking at these things right here, I should look to see where I am. This guy has 3, 4, 5, 6, 7, 8, 9, 1, 2, and then 10. So fluorine has 9. It has lots of protons for its row. Way more than 3, 4, 5, 6, 7, 8, 9. Okay? It's small. It has so many protons for its row, so it'll be able to attract electrons in its bond. So it's close and rich in protons. Notice if I said why, we'll be able to attract bonded electrons easily. Notice how attracting bonded electrons, that's electronegativity. Note how I said size and more protons attracted. Okay. Draw the periodic table to show electronegativity. Yeah, you should be getting better at drawing periodic tables. Well, this one's better than the last one. So remember, the smaller you are, the more electronegativity you have. So this has more electronegativity. Why? Because smaller. Now, why is it smaller? Remember down here, I've got a huge, and then smaller, and then smaller, and smaller. Okay. It also gets bigger as you go this way. Why? This is more electronegativity because more protons. Oh, I don't know what my pause button is, but I'll be like 2 minutes maybe. Okay. Ionic radius. This is the size of an ion. Cations are smaller. Why? Well, cations are positive, so they lose electrons. So if you lose body parts, if you start out as a knight that says knee, and you lose a knee, and you lose a leg, and you lose an arm, you end up smaller. Anions get bigger. Why? There are more electrons that push away, push or repel away. Okay, so they spread out and get bigger and bigger and bigger. Periodic table for ionic radius. Now this one's a little bit different because if you remember, 2, 3, 4. If you remember, you've got metals over here. So this is +1, +2, +3. So what happens is this is big, small. And then what happens here is you have a small, big for negative. So these guys are positive, 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 and small, negative, 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 negative. Okay. Valence electrons are your outermost electrons. So draw your periodic table for this one. You have 1, 2, 3, 4, 5, 6, 7, 8. And if you recall, we did this before. These each have 2. This is also periodic. So this guy has 1, this guy has 2, this guy has 1, this guy has 2. Valence electrons help determine charge. So if everything wants to be 8, this one's got 8, so it's wonderful. If I have 7 here, if I have 7 valence electrons, to get to 8, I need to gain a negative electron. That's why it's -1. If I have 6 and I want to get to 8, I need to gain 2 electrons. Since electrons are negative, that makes it -2. If I have 5 and I want to get to 8, then I gain 3 electrons. Now if I'm over here on this side, if I'm on the positive metal side, if I have 1, what really happens is I've got 1 electron out here and I've got 8 here. So I could either gain 7 or lose 1. So it's a lot easier to lose 1. So if I lose 1 electron, I become +1. And for this one, to get to 8, it's easier to lose 2, which would make you +2, than it is to gain 6. So this one would be lose 3, +3. And then this one does nothing because it's not worth the effort. I want to be full. 8 is great. Metals and nonmetals react differently. Metals lose electrons, they become positive. Nonmetals gain electrons, they become negative. The best metal reactor is francium because it's a big, unattractive loser. Big because lots of energy levels. Unattractive because few protons for its row. Best nonmetal reactor is fluorine. It's small, attractive stealer, not attractus. I swear I changed that. Small because few energy levels. Attractive because lots of protons. So on periodic table, the most reactives are bam, bam, and bam, bam. Noble gases never react though. Why? They are full of 8. That's an 8. Full of 8. Review: electronegativity, ionic radius, and atomic radius all have definitions you must memorize. Do you know them? I don't know. Size and attraction explain it all. Francium, fluorine are the most reactive of their types. Fluorine is the Mac Daddy. It means best at everything but size. And francium is a big loser like France. Toodles.